The first example for population growth is going to be number 8. So the problem says, a culture contains 1,500 bacteria initially and doubles every 30 minutes. So I'm going to write 1,500 initial, double every 30 minutes. Find a function that models the number of bacteria n of t after t minutes. Okay, so that's A, part A. So I have n of t equals n sub 0 e to the r t. Okay, so in order to do this, what we're going to need is well, first of all, we can substitute in what for initial? Good. And we don't know r, so we're going to have to figure out what r is. It tells us that it doubles every 30 minutes. So at 0, it's 1,500. Okay. At 30, how much is it? 30 minutes. How much is it? 3,000. Okay. So we're going to use these 2 points, or we're going to use this point to solve for r. This is our n of t value. This is our t. So we say 3,000 equals 1,500 e 30r. Because this is our end value, in this point, after 30 minutes, it's 3,000. So 3,000 would be our end, because that's what we get in the end. We start with 1,500. And we're saying 30 minutes, so we fill in 30 for t, and we're going to solve for r. Now, these are equations, exponential equations like we've been doing before. So the first thing you have to do is isolate the exponential. So what do? You want to get the e to the 30r by itself. So what do? Good. And what are you going to get? 2. Good. So we get 2 equals e to the 30r. Now what do? Good. Why did you use ln? Because e cancels out. Excellent. Good job, guys. So ln 2 equals 30r, and now what do? Divide by 30. So r equals, excellent job, ln 2 divided by 30, which gives us 0.023. I want to say 0.0231. So this part A asked us to find out what the equation is. So we filled in 1,500. Now we can fill in our r, which is 0.0231, and we'll leave t, because t is like our x value. So this is our answer to part A. Part B is actually much easier. It says find how many bacteria are after 2 hours. Yes. E is a number. It's the natural number. It's 2.718, I believe. 2.718. We've been using it for a while. Okay. So B says how much do we have after 2 hours? So what do we do with this equation? For t, what do we substitute in? You substitute in after 2 hours, so you substitute in 2. So n of t equals 1,500 e to the 0.0231 times 2. And then you solve. So we just put that straight into our calculator. 1,500 times e to the 0.0231 times 2. And that gives us 2 hours. I made a mistake. What was my mistake? So when we did T, what do we do here?
It was in minutes.
It was in minutes. And when I did T here, what did I do?
You put 2 hours.
I put 2 hours, not minutes. So what needs to go in here?
120.
120.
Oh, geez.
Good. So remember, if you want to just get what you had before, you hit second entry and everything will come back, and instead of 2, we can put 120. And there's the correct answer. 23,985.87. Okay. I'd like to solve for C. Part C now. Part C says Part C says this. After how many minutes will a culture contain 4,000 bacteria?
I have no idea.
So, when they give you 4,000 bacteria, is that the start amount or the end amount?
Start.
Always. And always the start. Always the start.
Listen, the problem says, after how many minutes will the culture contain 4,000 bacteria?
Yeah.
That's the end. So we put it in the end spot. We leave 1,500 e to the 0.0231 t. I will wait for you guys. So we put it in the equation that we had, and now we're going to solve for t, much like we did in part A. So what did we do first?
Get the thing by itself.
Right, so what do you do? Good. And then what? Now what do you do? What do we do here?
Oh, you take ln.
Take the ln of both sides. And the ln and the e will cancel. So we have ln of 4,000 over 1,500 equals 0.0231 t. Last step. Good. And then we put this in our calculator. So ln of 4,000 divided by 1,500 divided by 0.0231. And that gives us 42 minutes. Or 42.46 minutes.